Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we'll see a oscillating motion problem. So the problem statement is very simple. We have a double acting cylinder and pushing the start button, the cylinder will move forward and backward in a sequence. So it will be a oscillating motion and I have a stop button to stop the operation. So let's draw the circuit. It will be solenoid operated on both sides. So here goes the pneumatic part. Now let's draw the electrical part. I will use a dominant off latching circuit. So this is my push button 1, this is my push button 2, and this is my relay K1. This is my latch connection limit switch which will send K1. Okay, so this limit switch also senses K1. This physical limit switch which is at the cylinder side. First let me give the cylinder identification. This is A0 and this is A1. So this limit switch will sense A0 position and this is my K2 relay. Okay, now for the solenoid part. Okay, so this limit switch will sense K2 and this solenoid is Y1 and I will link this solenoid to the left side of this 5/2 DCV. If the cylinder extends, then I need another limit switch to sense the end position. So I have another physical limit switch which will sense the A1 position and this relay is named K3. So when K3 energizes, this limit switch will get activated and this solenoid will be energized. Okay, so this limit switch will sense K3 and this solenoid is Y2 and I'll link this to the right side of this DCV. So this is the overall solution. Now let's see in the fluid sim software. You will understand better there. Okay, so here is the circuit. I exactly did what I explained. So let's identify all of this. So this push button will be the start. This push button will be the stop. This coil will be named as K1 and this limit switch will sense K1. This solenoid is Y1. This solenoid is Y2 and the left side will sense Y1 and right side will sense Y2. This limit switch also sense K1 and there will be a physical limit switch here which will sense the A0 position. And this limit switch also physically present at the cylinder side and this will sense A1. This coil is K2, this coil is K3 and these two limit switch will sense K2 and K3 respectively. So I have made all the identifications. Now let's simulate. Start. Let's go single step, pressing the start button. So what will happen is that this side is closed. K1 is energized. This limit switch will be closed contact. Now this K1 will be also closed and A0 is the initial position. So this normally closed will stay normally closed. The K2 will get energized. Because of that, this limit switch will get closed, Y1 will get energized, and the left side of this 5/2 DCV will actuate. Let's see that. See, already the cylinder is extending. So what will happen next is at A1 position, this normally open limit switch will be closed. Then K3 will get energized. Following that, this Y2 will get energized and the right side of this 5 by 2 DCV will actuate and the cylinder will retract, moving to the A0 position. As the circuit is latched, this contact will never break. So at A0 position, this limit switch closes, K2 energizes, following Y1 and the cylinder extends and the cycle repeats again. Now let's see in the normal speed. Clicking the start button, see it's working perfectly. Now to stop this motion, I have to click the stop button here and the cylinder returns to its initial position. So this is the solution of this problem. Compared to the pure pneumatic system, this might look a little bit difficult, but when the problem itself gets bigger and complex, then solving with the electro-pneumatic system is very easy compared to the pure pneumatic system. So that's all for today. If you have any confusion, then please write in the comment. See you in the next video. Allah Hafiz.